Write all possible chain isomers with molecular formula C5H11Cl. Let us first determine the degree of unsaturation for this elemental composition to know whether it is a saturated elemental composition or not. Degree of unsaturation is equal to 1 plus number of carbon atoms minus number of hydrogen atoms by 2 minus number of halogen atoms by 2 in this case. Therefore, this is equal to 1 plus 5 minus 11 by 2 minus 1 by 2. This will become 0 because this is 6 minus 5.5 minus 0.5. Therefore, this is a completely saturated elemental composition. That means no carbon-carbon double bonds or rings are possible. This is no. Let us write the structures one by one. We can definitely write 1-chloropentane. I am going to write all the structures in bond line notation. This is 1, 2, 3, 4, 5 and then the carbon chlorine bond. This is 1-chloropentane. We can also write 2-chloropentane. 1, 2, 3, 4, 5 and then carbon chlorine bond at 2 position. This is 2-chloropentane. And then we can also write 3-chloropentane. 1, 2, 3, 4, 5 carbon chlorine bond at 3 position. This is 3-chloropentane. We cannot write 4-chloropentane because if we do the numbering left to right, then that will become 2-chloropentane once again. Therefore, writing 4-chloropentane is a repetition which we must avoid. And then number 4, we are exhausted with the pentane chain. Let us go to the butane chain. 1, 2, 3, 4, then one methyl group at 2 position and then carbon chlorine bond at 1 position. And this is 1-chloro 2-methyl butane. 1-chloro 2-methyl butane. Even though methyl and chlorine both are substituents, we have to mention chlorine first because as per alphabetical order C comes first before M. And then we can also write 1-chloro 3-methyl butane. 1, 2, 3, 4 and then the carbon chlorine bond and then the methyl group at 3 position. So, this is 1-chloro 3-methyl butane. And then number 6, we can also write 2-chloro 2-methyl butane. 1, 2, 3, 4, both the methyl group as well as chlorine at 2 position. This is 2-chloro 2-methyl butane. And then we can also write 2-chloro 3-methyl butane. 1, 2, 3, 4 at 2 position chlorine and 3 position methyl. 1, 2, 3, 4. This is 2-chloro 3-methyl butane. We are exhausted with the butane chain. We cannot write 3-chloro 2-methyl butane because that would become a repetition. For example, if you write an isomer like this 1, 2, 3, 4 and then here chlorine and here methyl, then once again if you name it, then you will reach to the same thing. Therefore, that's a repetition. And then number 8, we can also write a propane isomer, that is 1-chloro 2,2 dimethyl propane. 1-chloro 2,2 dimethyl propane. These are the 8 isomers that we can write for C5H11Cl. The reason why we did not put both the methyl groups at 1 position when it comes to propane is because that will once again become a repetition. That's the reason we directly put it at 2 position. If you put it at 1 position here, then that will become 2-chloro 2-methyl butane, isn't it? So that's why we did not put the methyl groups at 1 position. Anyways, let's talk about the chain isomers. For any given 2 isomers, if the parent chain and or side chain are different, then they are chain isomers. On the contrary, for any given 2 isomers, if the parent chain and the side chain are same, then they are position isomers. Let us distinguish between chain isomerism and position isomerism for every possible combinations in this case. 1 and 2. Are they chain isomers or position isomers? 1 and 2 are definitely position isomers because the parent chain is same, side chain is also same. Only the position of the chlorine atom differs and therefore they are position isomers. How about 1 and 3? 1 and 3 are also position isomers. Parent chain is same, side chain is also same. How about 1 and 4? 1 and 4 are chain isomers because the parent chain in 1 is pentane and in 4 it is butane, and plus the side chain methyl group is there in 4 but it is not there in 1. Therefore, 1 and 4 are definitely chain isomers. Likewise, 1 and 5 are also chain isomers because parent chain itself is different. 1 and 6 chain isomers. 1 and 7 are also chain isomers. 1 and 8 are also chain isomers. Now, how about 2 and 3? 2 and 3 are once again position isomers because the parent chain is same, only the position of the side chain, which is the chlorine atom, that differs. And therefore, 2 and 3 are position isomers. How about 2 and 4? 2 and 4 are chain isomers because parent chain itself is different. Therefore, 2 and 4 chain isomers, 2 and 5 chain isomers, parent chain itself is different. Likewise, 2 and 6, 2 and 7 and 2 and 8 are indeed chain isomers. Now, how about 3 and 4? 3 and 4 are also chain isomers because in one case you have pentane as the parent chain, in another case you have butane as the parent chain. Therefore, 3 and 4 are chain isomers, 3 and 5 chain isomers, 3 and 6 chain isomers, 3 and 7 chain isomers, 3 and 8 are also chain isomers. Now, how about 4 and 5? 4 and 5 are position isomers due to the methyl group. Parent chain is same, butane. Side chains are chlorine as well as methyl, but the position of chlorine is same, but the position of the methyl group differs. Therefore, 4 and 5 are position isomers due to CH3. How about 4 and 6? 4 and 6, parent chain is same, butane. Side chain are also same, but their position differs. The chlorine atom position differs. Therefore, 4 and 6 are position isomers due to the position of the chlorine. How about 4 and 7? 4 and 7 are also position isomers, but this time due to both chlorine as well as methyl group, because parent chain is butane. In 4, the chlorine is at 1 position, but in 7, the chlorine is at 2 position. And in 4, the methyl group is at 2 position. In 7, the methyl group is at 3 position. Therefore, 4 and 7 are chain isomers due to both chlorine as well as methyl group. How about 5 and 6? Likewise, 5 and 6 are also position isomers due to both chlorine as well as methyl group, because parent chain is same, side chains are same, but their positions are different. 5 and 7 are position isomers due to chlorine alone. Methyl group position is same, isn't it? Now, how about one combination looks like we miss? How about 4 and 8? 4 and 8 are chain isomers. Let me just write down here. 4 and 8 are chain isomers. So, 5 and 7, how about 5 and 8? 5 and 8 are position isomers. Let me write it in next page. Chain isomers 5 and 8. Likewise, 6 and 8 are also chain isomers. 7 and 8 are also chain isomers. How about position isomers? Did we miss anything? How about 6 and 7? 6 and 7 are position isomers. 6 and 7 are position isomers due to methyl group, because the methyl group positions are different. In 6 it is at 2 position, in 7 it is at 3 position. Therefore, we got all possible combinations here. Total 28 different combinations we should have for chain as well as position. We got that. We got all of those here.